think it's time to start. Welcome to the Build a Single Page Web App with Play and Knockout talk. Just to poll the audience quick, how many of you guys are familiar with Knockout? Anyone? How many of you actively use Knockout at work? Great, cool. Okay, so I think for a lot of people this is going to be somewhat new. This is a very introductory talk to Knockout. Let's start off with who we are. I am Josh Suereth. I'm a senior software engineer at Typesafe.
And I'm Maxime Dantek. I also work at Typesafe as a designer and front-end developer.
So this talk is all about one-page apps. We work on a product at Typesafe called Typesafe Activator, and we've chosen Knockout to do it. So we're going to go into that.
So basically, we are going to build a Tic Tac Toe game, a reactive style, using Knockout on Play. And so we are going to use Play's WebSocket. Basically, the only feature from Play will be the WebSockets and Knockout.js, and then a bit of jQuery. So what is Knockout? It's basically the library to build one-page reactive apps. So it uses extensively two-way binding to tie your HTML code and your JS code. So basically, it will help you define some variables in your JS code and use those same variables in your HTML code, and when one is updated, it's updated in both. So if you're using a formula and you have a new value in your input, you can get the value back into your JS, and if you're changing the value in the JS, it will also update your HTML. So that's a two-way binding. It's enabling the functional reactive programming by using observables and computed values. So observables basically are just functions that you can use in both HTML and JavaScript. And it's also using a lot of template helpers, such as loops, so that when you update a value in your JS, you can have, let's say you have an observable array, you have 10 values in your array, and so you want to have the 10 values in your HTML, but when you delete or add new values, you want to update your HTML view as well. What Knockout is not, it's not a framework. So basically, it doesn't provide any configuration or routing. You have to do it yourself. That's the main difference with the competitors. So who of you have already heard about AngularJS? So yeah, that's most people. And Ember.js? Okay. So there is also Backbone.js, but since it doesn't provide a two-way binding, we're going to skip this. Okay. So basically, we are going to play good cop, bad cop to explain what the main advantages from those framework regarding jQuery or Backbone.
So the good things about Knockout, Angular, and those kind of things is you get this automatic binding into your HTML. You get a lot better readability of your code. The code tends to be a little more cleaner, and you have these really powerful HTML syntax elements that you can do. One of the other good things about Knockout compared to the other things, and it could be good or bad depending on your viewpoint, is it's just a library. All of the other competitors out there that do the same thing are actually full stack frameworks, force you into a convention.
So for the downside, the main one is really debugging. You can't put a breakpoint into your HTML. You can't console.log your HTML. So if you do data bound instead of data bind, nothing will happen. We'll have no error at all. And it's the same for the testing. The testing part is really hard when you can't really test your HTML without running your whole code using Phantom.js or stuff like this. And so it's related to having a powerful HTML. I mean, you put a lot of things into HTML, you don't have any type safety. You can put whatever you want. If you don't close a tag, you won't have any error, and you have absolutely no way to find what's wrong with it. So why did we choose Knockout? So like Josh said, we are using Knockout in Activator, and so the main reason was really because it's lightweight and it plays nice with jQuery. So in Angular, so for those who already tried Angular, Angular doesn't play well with jQuery. They had to re-implement the jQuery APIs right in Angular. And it also has a soft learning curve. You don't have to learn much to start with Knockout. There is actually a really good tutorial on the website with a few steps, and you can go through all the main part of Knockout, like we are going to do now. and it also has a really readable documentation. So this is code time. So do you have any questions so far?
All right, we're going to walk through the Tic Tac Toe application. This is just showing I started up Play, and it's in run mode. So as we make changes, it's automatically going to update, and I can refresh in the browser, and this is going to be compiling our code and doing anything that it needs. So that's the end of the build tool. One thing that we're using here, we're using WebJars to pull in the JavaScript we're going to use in Play. So in Play, these are Maven coordinates. So here we're pulling in Bootstrap and we're pulling in Knockout with WebJars. I'll show you how that shows up later. The nice thing is you can actually use Play to maintain your JavaScript versioning. And then inside of WebJars, we'll actually just say, give me the jQuery minified JS file, and it will give it to us. So we can control versioning the same way we control versioning with all our other JVM artifacts. So that's kind of a nice duality there. It makes it a lot easier to upgrade libraries if you make use of this feature. All right, the next thing that we'll show is actually the routes file in Play. This is how I like to think when I think in a Play app. My routes file is all the URLs that I handle and the controllers that handle them in Play. And this is rather small, and this handles the entire Tic-Tac-Toe game. The only route we really need is to serve our index page with all of our JavaScript. And then, or the routes we need to serve all of that stuff, that is here. This serves our index page. And then we have these assets where we can serve local images, CSS, that sort of thing. And there is also the WebJars assets where we can serve up the JavaScript that we've resolved via Maven. This route here and the engine, one of them is the WebSocket, that's the top one. That's going to be the WebSocket connection URL. And the second one is actually going to auto-generate some JavaScript code to tell the JavaScript where the WebSocket is. So the only tie in the JavaScript to this particular URL and the username, port, whatever we're using, is actually going to be via this generated JavaScript. So we shouldn't have to change our JavaScript when we move our server around or change the URL and that sort of thing. So that's what that's all about. Let's take a quick look at that controller. In the socket controller, for the JavaScript routing, there is a JavaScript routing handler now in Play where you can write out this JavaScript. This is Scala code. So I chose Scala here because the WebSocket code is a lot cleaner or shorter and fits on a slide. But it's pretty similar in JavaScript. So when we connect to a game server, what we're actually going to do is we're going to create an actor system using akka. The whole game engine is written in akka using actors. We're not going to cover any of that here. That's not important to us. We're web developers. All we care about is the JavaScript and the API. So we define a WebSocket that is going to use this particular type to communicate back and forth. JS value is Play's JSON type. So we say we're going to send JSON types in and out. Here we create our output channel with a particular type that we can use to send messages. We're going to create a function here that anytime it gets a message, it's going to push it out the channel, and we use that to instantiate the player actor in the actor system. If you're not familiar with actors, you can just pretend this is magic. It doesn't matter. The point is we're sending anything that we want to send out the WebSocket from the actor. This is us connecting it to the output channel from Play. Here we're creating an input channel where every time we receive JSON, we're going to take the JSON and just send it directly to the person actor that we've created. So any incoming message we send out. And the result of this is going to be the input and the output channel. And that's how you create a WebSocket in Play. This map method, I kind of hate that this is how it looks, but essentially what we're saying is when you get to the end of input from a WebSocket, meaning when it closes, do this. And do this is we send a poison pill to an actor, and that is their API for terminating or shutting down the actor. It's a bit vicious. So, yeah, we should step into some JavaScript.
I will show you some HTML first, I think. So we have, so for those who are familiar with Play, so we can use the templating system. Templates are just functions. And so basically the main file for Is it the right judgment?
Oh, yeah. You want this guy here.
Okay. So here we are using the main function that Josh showed you earlier, and we basically have our UI here. So we have a body, a header with a title and a main. So as you can see here, there is an index function, and the other important part is in the main.html. Sorry. So it's a socket here. So it's in this file because we are using it in the debugger page. So if we look at the socket, so this is a file. It's a small library to handle WebSockets from the JavaScript hand. So basically, we are binding the event from a WebSocket. So we are opening it with a nice play.js root file. So we are just typing controller extra, and if we change the root for this particular WebSocket, and by keeping the same controller name, it will just find its way.
Can I make a... So you see window.server there? You should never, ever do that. This is an example app, so please don't copy window.server. You should use something like require.js, and this should be a full library, like for real. But yeah, if you see window.server, that's for debugging purposes for this demonstration. Don't mimic that. Anyway, back to WebSockets.
So really quick, we have a buffered array. If we have messages that comes in before the socket is open, we just store them. And here in onOpen, the onOpen event, we call that function that says, okay, we are live. And for each buffered message, we just send them back to the server. We also have an onError handler and a send function. I will go back to this one after, actually. And the most important one is actually this one. So the set message handler. So it's here that we will pass the function to whenever a message comes in, it will go through this part of the code. So we have on message listener, and the real listener here will be able to handle any kind of messages. So the server will we always send strings, and we will just pass them into JSON so that we can manipulate them into our code. And the send function can take either a JSON or a string, and it will convert it into a string to send it back to the server. And to describe really quick the basic of our code here, we are just describing some random names for the usernames and an empty board.
Yes, so this is the oh yeah, we should. Yeah, cool. So this is the debugger where we can actually we have that socket hooked up, and we have a generic send message API where we can just send messages down and see what the socket returns. So of the API, the only thing that's actually important to us to implement the entire game is we can send a request to find us a game, and here's our name, and we can say I want to move somewhere. Here's where I want to move, and this is my game ID. So if we send down a request to join a game, we're going to send that down. We get an error that says no games exist, create that yourself. That's my bad. That actually shouldn't be making it down the WebSocket, but I was lazy. Everything makes it down the WebSocket. Yay. Okay, and then we get a response that said, hey, you joined a game, and you are player X, so you're going to be the X turn, and this is your game ID. It's a UUID from Java. And then later on, a few seconds later, actually almost no delay, we get a board state that says, hey, here's the state of your board. In that board state, you can see the board is actually 3 arrays of 3, where null represents no one has moved in that spot, X represents somebody has moved, and O represents O has moved, right? And then it will give you whether or not there's a winner. Right now, null means there's no winner. And X here represents the X player's name. And when a Y player joins, we'll see Y with the Y player's name. So that's the response from the server. This is the API we're going to be dealing with. After we've joined a game, we can actually try to move. And we got to give it the game ID, which is way easier to just cut and paste here. And we're going to send that down. And you're going to see we get a board state request. And if you look right here, you'll see X has moved in that location. Great. If we try to send this same thing again, it's going to say that was an invalid move. Sorry, guys. So this is our API. This is what we're dealing with the WebSocket. Things are coming in and coming back. Okay? So let's start looking at building up our Knockout app. This right here is our board model. In Knockout, the general way that you design your code is you start with a model class. And JavaScript doesn't have direct classes, and we're going to be using raw JavaScript here. If you have a helper method to use class or using CoffeeScript, that's great. You can do that too. This is just going to be raw. So you start with your direct observable state. This is state that you get from the server or that you're writing directly from your UI, which is direct and important. And then you can actually do derived state, things that I can compute from other properties I have. We're going to place here, and we can use these to drive other UI features. We'll get into that in a bit. Here's where we're going to throw all our message handling of things that come back from the server. We're going to take the data we've gotten and bind it back into those observables we defined as our direct state of the application. And then we're going to find a bunch of functions, which are actions that you can take when, say, the user clicks on something or a form gets bound. So I just want to highlight that. We're going to go into details right now. So,
HTML.
What?
HTML.
HTML?
HTML time.
Yeah, HTML time. That's your time, man. Okay, so we have our UI, and Maxime already wrote a form for us that I'm going to autocomplete while you're talking.
So we are using a really basic JavaScript here, HTML here. So it's a simple form, and I do all the magic basically with the CSS. So what you will see is enabling with CSS, and we are not talking about CSS today. So just to say, we are using simple HTML and simple JavaScript to this talk. So this is a regular form, as you can see all the time. And we are going to bind some knockout actions to it. So we've put our form here. It doesn't do anything. You can click on Find Game. There is nothing binding yet. And it's just refreshing the page right now. So the first thing to do is to provide some data bindings.
So inside of our model, what we're going to do is we're going to create an observable. And the observable is going to be the name of the player. What do they call it? Just name?
Yeah. You call it user. And,
right. We call it user. Great. And inside of here, we're going to use that nickname function you saw above to give ourselves a default nickname. And then inside of the HTML, we're going to bind this. Oh, right. So now we have a board class that has a user observable in it. An observable is something that you can set and get, and it will fire notifications when you've set or got it. So then we're going to actually apply our bindings here, where we construct the model. We're going to throw it on window again, just for debugging purposes, so we can show you stuff in the console if needed. And then we call this apply bindings. Apply bindings will take the model and look at your HTML for any data bind element it has, and match the observables together in that two-way binding fashion.
Is everybody able to see what's written on the board? We can.
Oh, is it too small?
Yeah, I think it's. I don't. Oh. Do you see in the back? Okay. Yeah, you can. Perfect.
How's that? Okay. So I need to come back to here and do that as well. So here's where we created the observable. Self.user equals knockout observable with a particular the nickname that was generated. And then down here is how we apply bindings to bind this to the HTML. So
the first thing in the HTML, we're going to provide that data binding. So since it's an input, we are going to use the value binding. If it was a span or div, we could have used HTML or text binding. So this will actually enable the state to be changed both in JavaScript and HTML. If you change the name here, the state in the JavaScript will change as well.
Oh, right. We have to click it.
Oh, yeah.
Yeah.
So all observables are functions in Knockout. So basically, you declare your observable with a ko.observable function or ko.observable-array function, and you access to that value with a function passing no objects, and you change the value by passing an object. And it automatically changes everywhere it exists. So in the HTML or in JavaScript, it will automatically change and update it as soon as something happens.
So next up, we're going to actually figure out how to have the user log in and try to attach to a game. So to do this, Tic Tac Toe, do you remember?
No.
Yeah, the font's killing me.
It's stupid.
Login form, action, supply bindings. Oh, right, GNG. There we go. Okay, so we're going to create a getNextGame function. The getNextGame function is going to, we're going to cover that in a second. It's going to send the server the find game for player, and it's going to grab the current state of the user observable. So what we do in index.html here is we're going to bind this action to the observable. So on submit, we're going to call getNextGame. Now, when we come in here, actually, let's do that. And we click Find Next Game. If we check it, take a look at model or board.user, you'll see that it's up to date and it sent something down to the server, which if we look here, you can see it writes out, yes, we sent down to the server and we wrote you back, you were joined, you are now the X user. Okay? So that is how you add actions for the single page web app. But now we need to start transitioning, right? We have done our login, and we need to transition to another state in our web app and have kind of a different looking UI.
So,
Oh.
Okay. It's okay.
Oh, I was going to, yeah, I can type if you want to talk.
So we are going to use another binding, which is called the CSS binding. So it will actually change the class value of a div or whatever by using an observable. So here we are going to use isLogged in observable that match if you're logged in already or not, and we are going to use it right into our HTML to change a logged class.
So what I was doing when Maxime was talking was I created the logged in observable, and when we click the getNextGame function, we're going to update that observable with a new state of true. Like once the user clicks that button, they are logged in, and we don't want to show the login API anymore. So that's how we're going to switch between the two states. And then inside of the HTML, we're going to update our data binding here with CSS, DB CSS. Okay, with this data binding. So we bind the CSS to, actually, this is the most complicated knockout data binding, I believe. So what we're doing is we're watching the logged in true-false observable, and if it's true, we add the logged class to this particular element, right? So that's saying which class gets bound if that observable is true. It's going to watch it and add and remove a class, okay? And if we refresh,
so what we've done here is right in the CSS, we are saying that if we have the isLogged class, we just get rid of it with a nice animation. So, and we are using that class to empower the next divs as well to be updated.
So, right, next.
Yeah.
Right. Okay, so next we need to show the board. Or, yeah.
I had to before.
Right, sorry. Next, there's an issue where after you've logged in and we take away the login dialog, you're actually waiting for somebody else to join the game. So we actually want to show a splash notification, hey, we're waiting for somebody to join. So we need a new observable for that, and we need to track when people have joined the game, and we need to handle the response of when the server tells us we've joined the game. So let's add the response handler.
So basically, in HTML and JavaScript, you always have a tied value. let's say here we can define the are you waiting for someone yet or not by the value are you logged in and is there someone else. So we are going to use another knockout powerful thing is it's the knockout computed values. So basically it's a function that returns a value, and so in that return statement we are going to use different values from observable or not. And what Knockout will do is that the first time you run that value, it will look for observables and tie them to that value, to that computed value, and as soon as one of them change, it will update the whole computed value.
Yeah. So the first thing we do is we have a message handler for our socket where when we get the join game response, if you remember from the debug page, that's going to give us the game ID. We're going to create a new observable to store that. So we're going to write it to something called ID. We're going to come back up here, and we're going to do an observable of ID, and we're going to start this off as empty. Now that computed observable, we basically want another true-false flag for that CSS because it's really easy to enable and disable elements via that. But we don't really want to lose or duplicate the information from logged in. We don't want to have to listen directly to logged in and say, if we're logged in and we don't have a game, So that's what computed is all about. So
basically we are using as a knockout.computed function. So we just as a regular observable, we are defining a self dot the name, whatever, and the function. So like I said, the return statement will tie the self is logged observable and the self is self ID observable to the is logged is joining game computed value. And as soon as one or the other is changing, it will change and send an event to is joining game value.
Yeah. So this function runs initially, right? And all the observables you touch are tracked. And then whenever one of the observables you touched before change, it's going to update this function. This is actually kind of the foundation of FRP. You're defining functions that access previous values, but the value is actually an event stream. And every time that stream changes, you get an updated value as well. And we can bind this directly into the HTML. So come over here, and we are going to create our alerts. So there's going to be a splash of, hey, we're looking for a game, and we're going to data bind the visible attribute of it to is finding game. And you notice, this computed, we're going to update the ID when the socket comes back, and we're going to update logged in when we click the button. But is joining game is going to be computed on both of those, so let's make sure that that works. I hope I saved. Is logged in, right. So what I did here is what I always do, is I wrote is logged in instead of logged in. So you should definitely have a convention in your code and stick to it. And when you make demos, you should actually use the same convention. Is finding game versus is joining game. Our template has is finding game. Yay. Here we go. So you can see it was popping up what the bindings were wrong on the right-hand side. That is what your debugging environment is for your HTML. That's actually what we consider the weakest part of Knockout. It can be rather frustrating when your bindings don't match up correctly or if you misspell things. Luckily there, it was obvious because we're auto-completing templates, but anyway. All right, so let's click on find a nickname. It's going to say looking for a game. As soon as the server responds with, hey, you joined a game, notice it disappears. So now our alerts are tied to these bindings and everything is automatically flowing. And now it's time for the board.
So the next step, we are actually displaying the grid. So first thing is that we are going to create a game div into our code. So let's just a regular div. And let's give it an ID game and close it. And we are going to see a new thing in Knockout. It's called the custom bindings. So as you can see, you have the submit binding, the CSS binding, value, text, HTML, etc. So Knockout provides a bunch of default bindings, but you could create your own, and that's what we are going to do now. We are going to create a board binding because it's convenient. So data bind just as usual, and we can say board is bind to board. Sorry. So I'm gonna save. And so let's go to the bottom of our code. So outside the board class, when I say class, it's a JavaScript object. We are going to define Knockout custom binding. So we call it board, as in the HTML. And so you have to provide two functions. The first one is init. So that one would be called on apply binding. So it's to initialize all your HTML and everything. And the update one will be called each time any related observable is changing. So you have a bunch of parameters that you can use for this. You have element, which is obviously the DOM object. You have a value accessor. So when I said board column, the value, it's actually a wrapper for that value. So you can access it's a function to access this value, and we will see after that you have a bunch of other things to do to control that value. And you have all bindings. So basically, it's if you put a CSS binding or a click binding on this very div, you can access all of them from your custom binding in all bindings. So this must be sorry. So what we have here is a click handler. So we are not talking about the click handler yet. It's going to see in all bind. We are going to provide it in another binding, and if it doesn't exist, like right now, we are just having an empty function. So we could use a direct reference for the click handler. We could use a direct reference to our JavaScript code. But to avoid side effects and being more composable, it's better to provide a function from another binding or even as a value if you can.
Yeah, so basically what's going to happen is we have that board binding to bind the state of the board array in our objects, but we also want a click handler, so when you click on the board, we don't want to give you a mouse event, right? We're defining the whole board. We want to give you the row and column. So this click handler, the whole idea is we can have an optional binding. If you have a board binding, you can also have a click handler binding where the function will receive the row and column that someone has clicked on. So, and that's a board click event, and we're actually creating that binding and creating that event from this binding. So it's a way that you can have things kind of correlate.
And so obviously a Tic Tac Toe grid is composed by 3 lines and columns. So 3 lines, 3 columns. So with with 2 simple nested loops, we are going to create our rows and columns as well here. And so thanks to JavaScript and scoping, we have to create an empty function just to get back the value. Otherwise, if you don't do that, you will have always row to 3 and call to assigned to 3. 3 assigned to call, sorry. And we are going to put some HTML here. So basically, the advantage of Knockout is to not having any templating in our JS code. This is just to show that you can use jQuery really easily into your code. But you can also define Knockout templates right in your HTML with a script tag. So we are just creating an empty div with a class box and a click handler that will be related to the click handler we've seen before. For our update function, so if I just refresh here, as soon as I'm joining a game, I will be able to see. Oh no! So I made a made a mistake in the HTML.
That's the wrong HTML.
Yeah.
Right there. Yeah.
Data binding board. No.
Oh, we don't have the observable board yet. In the model. Go up to the model. Yeah. We need to actually create an observable for board that we can data bind to.
Yeah, I should have.
Self.board.
Yeah, I should have chosen another name because I'm using board twice, which is confusing. Oops.
Yeah.
And I will pass the empty board value I have defined up here. So just empty board. Oops, sorry.
You have to tab, yeah.
Come on, Linux. Okay. Oh, it appeared right before.
Yeah. Wait till it.
No, it's supposed to be here. Right on. Maybe. Not.
Oh, it's not. Yeah, it's still hidden. We think we're missing some more data bindings here. I think this might be. Do we still need this guy?
Yeah.
Self.board. Okay. Is finding game ID board. Okay. And let's get rid of that because sometimes that causes issues. All right. No. All right. Should we?
That's
Do you
okay.
want to skip?
Yeah. Maybe we can continue to the update. We just need the update value.
We need what? Oh, update. Right. So sorry. We didn't implement update, which is kind of a problem because that's what actually writes the data. So we were creating empty div elements which don't have anything in them, which is what you just saw. Beautiful empty divs that don't have X or O in them.
So that's annoying. So like we said, we have no error, absolutely no errors. So the only helper that you can have is reread your whole code. And
well, yeah. No, we can take a look at other things, but we'll skip to the final solution then. The important thing about this update method here is this is called every time one of the observable changes. So every time we write in that board from the server, this is going to get called, and it's our ability to go in and update the actual table itself. So here, we're just basically going through the board, looking through all our divs, figuring out the row and column based on the index, and then writing the value into the text using jQuery. So this is how Knockout and jQuery can kind of work together for things. If we come back here, I'm pretty sure that we're not actually writing things correctly. Div ID game. If you look here, you can see all the boxes are in place, but our CSS is a little off, and I think it's actually our ID. I think the ID needs to be board, if I recall correctly. Yeah. So perhaps not. What happened was that div is on the other laptop, so I'm going to cheat. And TTT full HTML, or complete HTML. Okay, and it should have been an ID of game, data bind board. Do we call it board or game, or?
Okay. Sure, it's game.
All right. So here, if we refresh, all that stuff is going to show up because we just threw all of our HTML without any of our data bindings. So now we're going to put here the complete JavaScript. And you can see in the completed JavaScript, there's a few more things we had to add beyond the board. So we'll just go through those real quick. One is the server tells us what the player you are is. Are you X or are you O? So we're going to bind that as an observable. It tells you who is the X player and who is the O player, okay? Separately by name. And then we're actually going to have a turn observable as well. So has active game is a way we can tell whether or not there's an active game available. We're actually going to switch on self.player. And we're going to say if we are X or O, there's an active game because we are a player in this game. Otherwise, it's not active. We're also going to say whether or not we're searching for an opponent. If we're the X player and there's no O player in the game, we're still waiting for somebody. So we'd like to show an alert that says you're waiting for an opponent. We're actually going to compute text values here that we're going to use to display in the code. So here we look at our player. And if it's X, we say the X player text you show in the little box for players is going to be you. Otherwise, it's going to be who the opponent is. And same for O player. And then is done is fun. We check to see if there's a winner. The winner returns tie if there's a tie, X or 0. So we can see if we're done. And here we have a computed for tie if the winner is tie. Now here's where it gets interesting. When we want to find out if we won, we get lazy and we say if we're a player in a game and the winner of the game is also our name, we've won. For lose, we say if we're done and it's not a tie and it's not a win, we won. Now notice how we're chaining these computeds, right? This computed is making use of other computeds. And the only time this computed is rerun is if that other computed runs and gives a different value. It's not going to fire events when anything changes. It's only going to fire events if the value changes itself from one of the underlying things. So this is actually pretty useful to kind of limit the scope of these event firings. And that's actually a really important thing in Knockout. You really want to limit the amount of chains that things go through. If you have all of your UI driven off one observable, anytime someone touches that thing, your whole UI is going to try to see if it needs to update, and you're going to see really huge slowdown. But if you can kind of make these layers, it actually really helps improve performance. And finally, we actually made our message handler a little bit better. I would recommend, if you're doing that, to have a separate function to handle each type of message. It just is a little cleaner design. And in actions, we added the move action. So here we have, when we request a move, we send the move method down to the UI. And in the index, you'll see we have our we have get next game, and here's our other action. On the click to the board, we call the move method. Okay, so let's save, and let's do a big old refresh. Okay, now if we join as dark riff, you'll see the game board pops up, we are joined, and we're awaiting an opponent, because we do not have one. If you wanted to try to play this game right now, it is available at reactivetictactoe.herokuapp.com. The first person to log in can play against us. Yay. Tic Tac Toe is so exciting. I'm sure that everyone will tie, I hope. And yeah, that said.
Yeah, I think it's...
if you guys have any questions, we wanted to save some time for that. So, any questions?
So either about the app or Knockout itself, or even play, because we went really quick on play WebSockets. Okay, fine. Great, thank you.
Yeah, so, you might have to skip and refresh. I think I logged in on a different network. Okay. All right. Did somebody else join your game? That could possibly what happened as well. Oh, there we go. We're X. Who's White Wombat? Anyone? Oh, okay. There goes the game. Opponent quit on us. All right. Anyway, do you guys have any questions about Knockout or single-page web apps in general? Yes? No? Okay, yeah. The last thing I'd like to say about just this style of single-page web app is in Knockout, you're using these hidden tags and things to actually flip between states in your app. So your entire HTML, all of your templates and things, kind of get derived from that first index file. So one thing that we've done in Activator to kind of handle that is you can actually have custom view binding things where you can put templates in other files and pull them in. Eventually, everything is on the same HTML file, but that is a possibility as well in Knockout. The other thing I wanted to mention, when we were taking in messages and we were binding them back into the observables, you notice we have in our code a little bit of ugly. Where's the responses are up here. We have a little bit of ugly self.board, message.board, self.xplayer, message.x, that sort of thing. You can actually, there's a plugin for Knockout called the mappings plugin. So you can actually just take objects and turn them into observables and vice versa and get a much better, richer syntax there. So you have really one-to-one mapping. If you need control, you can get back control. In any case, thank you guys for listening. Hope you enjoyed it.